Welcome to another episode of the MSDN Show. Now in this episode we're going to cover an overview of the .NET architecture, an important new architecture coming out of Microsoft to help you develop your applications. Now as an overview, we're not going to necessarily dive in too deep into the architecture of .NET because there's an awful lot to cover. But hopefully we'll give you a nice, good understanding of what .NET is and how it can be applied to your applications and your solutions. But before we get to that, let's check in on the news.
Hello, I'm Erica Wickers. Welcome to the MSDN News Update. Microsoft has made available a pre-beta version of its .NET Framework SDK. The SDK includes a command-line version of the C# compiler, a minimal version of the .NET runtime, a debugger, sample applications, and documentation. This is the same version that was released at the Professional Developers Conference last July. To read more about this release and to find a link for downloading the 86 megabyte installation, check out Bobby Schmidt's Deep C# article at msdn.microsoft.com/voices/deep.asp. On October 10th, in numerous cities around the world, Microsoft will host Developer Days 2000, a one-day developers conference to provide the latest technical information to a broad audience of developers. This year's focus is how to build a web-enabled solution from planning to implementation. Dev Days will provide specific information about the .NET architecture and how it can play a crucial role in this scenario. To learn more about Dev Days, and if it will be at a city near you, visit msdn.microsoft.com/events/devdays. The upcoming release of Exchange 2000 Server includes an instant messaging service based on the RVP Wire protocol. This protocol provides developers with a programmatic interface to the instant messaging capabilities built in Exchange 2000 Server. Because RVP uses extended HTTP, it allows the use of existing flexible and well-known technologies such as firewall support and proxies. To learn more about how you can add support for the RVP protocol in your applications, read the article at msdn.microsoft.com/library/techart/rvp.htm. For more information about Exchange 2000 Server and to order a copy of the current release candidate, visit www.microsoft.com/exchange. On August 11th, Microsoft released to manufacturing the latest and most powerful version of Windows 2000. Windows 2000 Data Center Server is designed for use in high-demand enterprise environments. It supports symmetrical multiprocessing of up to 32 processors, 64 gigabytes of physical memory, and 4-node clustering and load balancing. To learn more about these and other capabilities of Windows 2000 Data Center Server, check out www.microsoft.com/windows2000/datacenter. Microsoft recently shipped the new Speech SDK 5.0 beta. The new and improved SDK includes a redesigned COM-based Win32 speech API, detailed samples with source code, as well as documentation. The new COM interfaces represent a significant redesign and provide for faster programmability and flexibility of applications. You can find out more information about the Microsoft Speech SDK, including links for downloading, at www.microsoft.com/IIT.
At the PDC in July, Microsoft had an opportunity to show developers for the first time what this new .NET architecture looked like. Now, the .NET architecture is extremely important and there's an awful lot of facets to it. To help understand what some of that architecture is in this episode, we're going to be sharing you the architectural aspects of the .NET framework. In later episodes, we'll be talking about more different features, capabilities, such as programming and services and so forth. But this time, just focusing on the architecture. Now here to help us understand the architecture of the .NET framework is John Shushuk. Greetings, John.
Hello.
Glad you could join us.
Glad to be here.
You actually are an architect for the .NET framework.
That's correct.
And what does that mean exactly?
It means that a bunch of us at Microsoft have been working together across all the divisions at Microsoft to think about how all of the software that we're building is going to fit together to produce the overall solution, which is the .NET platform. So my job is to understand customer requirements, to think about the technologies that we could bring to bear on those customer requirements, and then work with the development teams to hook it all together.
And I suppose probably first and foremost to understand is what exactly is .NET? I mean, is it just a buzzword? Is it just a term that's kind of a colorful way of describing some client-server interaction stuff, or what is it?
Well, .NET is an umbrella term that we're using to describe all of the new innovations that we've been working on over the course of the last 3 years. And largely what it is it's a way to take the Windows DNA architecture and all the Microsoft technologies, and we've been working to really open them up and to internet enable them in a very, very deep way. And so .NET describes that new world of internet-enabled web services that give you a new way to stitch applications together to make developers more productive and to build a new kind of application that's pretty hard to build today.
I mean, it sounds on the face of it that, I mean, we have these internet applications that I can go to the internet and I can be on Amazon or Barnes & Noble or something like that, and they can be connecting to Visa, and you have this interconnectivity, this N-tier architecture. How is it different than that?
Well, so if you were to look at the most advanced sites out there, some of the ones you mentioned, Amazon, Barnes & Noble, and so on, the developers there are really smart folks. They've been back there building all this plumbing, and yes, they largely have many of the kinds of things that we want to do with .NET. But if you think about the amount of effort that was required to put together these solutions, it's pretty enormous. So I was talking to a company down in the valley the other day that does online payment, and they've got a developer devoted to each one of those back-end kind of connections that they have. They have another set of developers devoted just to producing the front-end UI. And it's an enormous amount of work for them, and the solutions that they've produced aren't in many ways reusable. So once they've got that solution in place, well, it's up and running. The next time they want to go do one, they have to go by hand reconstruct that solution. So if they're doing payment to Visa, Visa has a set of protocols that they need to do, and a developer has to go and learn each message that they need to send back and forth. They need to hook that up into their system in just the right ways so that all the plumbing works. And what we've done is we've taken many of those things that all these smart developers are out there doing today, and we provided a framework, a set of building blocks to make it much easier to put those things together. So that's kind of the first aspect, which is making it easier for developers to build these kind of solutions. But I think that there's a second, deeper aspect, which is if you think about all the applications that you've mentioned, if I go to Amazon, I've got my Amazon password, and I filled in my own information. Then if I go to Barnes & Noble, it's largely a different set of information that I filled in. And everywhere I go, I must have 30 or 40 different passwords. And I have...
I know, I try to keep like one username or one password I use everywhere.
Yeah.
But, I mean, where's the security on that?
Yeah, exactly. And so now you've got all these different islands, if you think about them. They're kind of separate apps that are all running out there, and they're not really connected together in any deep way. They may use the same web HTTP protocol and the same browser to get there, but there isn't a deep level of integration. But already we've started to see some examples. Things like Microsoft Passport give you a single login, and they start connecting together these sites. So I enter my user data once, and now I'm connected into a web of applications.
So is Passport using .NET?
I think Passport is a great example of .NET. So when you say using .NET, maybe that might sound a little bit confusing, because .NET is kind of an overall game plan. And so when you talk about using .NET, you could be using our servers, you could be using our services, you could be using the new .NET framework, which is a way to program. But I think of it mostly as a way to start hooking into this connection of web services as the key thing you're trying to do when you think about moving to .NET.
So then, using Passport as an example then, so Passport is not really a site you're navigating to as a user. Passport is an authority authenticator that is holding your username and password and authentication certificates there, and someone like Barnes & Noble or Buy.com or something like that would allow you to authenticate yourself through the services exposed by Passport. They would accept that authentication callback or whatever that says, yes, this person is who he says he is. I'm not telling you what his password is. I'm not telling you what all his Visa information is, but just take it on our authority that he's the right person.
Yeah.
And then move on from there. So now Barnes & Noble is not having to write that whole
That's
maintain
exactly
this
right.
database, maintain the username, maintain this sort of stuff, and cause the user to have a brand new username and password.
Yeah. So again, I've been talking to a bunch of companies, and it's interesting. Every company I went to would tell me about the cost associated with managing their usernames and passwords. It turns out that on the road over the past couple of weeks, it was the #1 call into their service centers was, how do I maintain that username and password? So think about the expense associated with just maintaining that database. Now, if you're a developer, you're probably thinking, oh, that's not that hard, right? All I do is I have a database, a couple entries in the database, I hook it up to the web page. Maybe there's a little bit of tricky stuff about getting the cookies right, and I got to avoid the replay attacks and so on. What Passport does is it bundles all that up and it keeps it up and running. But it also provides a bunch of infrastructure. So when you lose your username and password, there are ways for the developer to go, for the end user to go get that, for the developer to interact with that, and so on. So Passport's providing not just the software that you would need. They've tested it, they've integrated it with a bunch of other systems, they have processes that work, they keep it operating. Let me give you one more example. How many sites do you go to that have community forums where you can talk about things? Pretty common thing to do. And again, you're a smart developer. How hard is that? You go, you put a couple entries in a database, maybe use XML files, and you hook that thing up to a user interface. But you got to keep that thing up and running. You got to rev it. You got to make sure that all the sort options exist. So instead of doing that, what a lot of sites do is instead they turn to someone like MSN Communities or Cyborg, and they hook those things into their site so that they don't have to do all that work. And in a way, this is kind of the same thing that people were doing with component architectures. So when Windows first came out, it was a lot of work to go build a Windows app. And after a period of time, you could buy things like VB controls. You could just slap them together on the page, script them together, and you'd have a solution. Well, what people are doing now is they're hooking together and stitching together services to build that solution. And so it's more than just the software, it's the operations, the testing, the process that goes on to keep those sites up and running, which is the really big win in terms of productivity.
So then the smart individuals then are thinking through what is the core fundamentals of our functionality that we expose, whether it's maintaining user database or doing forum sort of stuff, and they embody that within a componentized architecture so that it's all nicely contained, and then some other application, some other site or whatever merely connects up and makes calls into it and then hosts that on their own. Is it like a frame-based hosting, or how does that?
So that's a great question. So there's a bunch of different ways you could do this. You could absolutely have those things just be UI elements, and that's the way some of the simple bulletin board mechanisms work. But I think developers are going to want another level. They're going to really want to control that from a code aspect. So instead of just creating a frame and having somebody else's UI show through, suppose I sent that information back as XML, and I could make those calls using HTTP and XML posts, get that information back, and then manipulate it in the way that I want, integrate it with my data, pull those things together. And that's the kind of thing that we think people are starting to move to. So already you see many sites out there starting to provide either their content or much of their information as XML available capabilities. There's a lot of work to be done, though. We've got to figure out what the business models are going to be, how to protect your site from people who want to pound on it. So there's a lot of folks in the industry spending time thinking about those problems. And I think we're on the cusp of a new architecture around those things.
Yeah, just trying to wrap my head around this a little bit better. Speaking like towards the Windows programmers in our audience, it seems there's a similarity here between the old OLE controls and the next generation, which was the COM components, where in the original OLE controls, it was basically a frame in your application that exposed Excel or Word or something like that, that the surrounding application had no control over. And then with COM-based components, you could actually take and embed the components and script against those components, ask them questions, pose them information. Sometimes the component actually showed visual information on the page. Sometimes it was invisible. and you were just, passing information. Is it the same sort of thing then?
It's exactly the same kind of thing. The only difference here is instead of that component being something that you manage each time, somebody else is going to take care of it for you. Now, you're going to have some challenges associated with that, right? This thing's going to be over on this other machine. And so
the machine is across the internet, across
exactly.
a firewall.
Yep. So we should, at some point in time, kind of walk through the mechanisms that you use to understand that object, how you discover it, how you make the calls. But we've got that component over there. We're going to make a call to it. Well, there's going to be some things like latency. So when we talk about building things this way, it's probably going to happen at a little bit different granularity than in the OLE-COM world, where you might do it at the micro level in response to a user call. Here, you're more likely to want to have things happen asynchronously. So, for example, I might have some feeds that are coming into my site where I'm getting stock information. And then I might collect that and integrate that with my data, and then in response to a user request, display that information. So it doesn't necessarily imply the same exact internal application architecture. It's more the model, but you're totally right on when you think about that as being analogous.
So what sort of application developers out there are going to have the most to benefit from adopting a .NET architecture?
Well, I think when we look around at the kinds of apps people are building, clearly many of the technologies we've built around things like direct draw and how we build end-user productivity apps, things like Word and so on, all that technology still is totally applicable. None of that stuff's going to go away. Where I think we start seeing the big benefits is when you start trying to tie people together, when you start wanting to do collaboration. So for example, let's say that we wanted to schedule a meeting together. Well, imagine if that our calendars were exposed through programmatic interfaces so that we could write a program that could look at both of our calendars, be assured that we had the right kind of privacy capabilities to be able to do that, could integrate that information and give us a solution. That's a little bit different kind of feel to the app, which is taking our inputs and maybe letting us edit a video or draw a diagram. Here what we're doing is we're getting the ability to bring together people, applications, organizations, and integrate those things and to collaborate. And that's largely what I think the promise of the web is. And today it's kind of interesting. It's mostly being used as a mechanism for delivering UI. And it's not until we get to this next level that we're going to start bringing people together a little bit more.
So will the user actually notice a difference in using a .NET application than using something that's not based upon .NET?
Well, I think over time, they absolutely will know that if they are .NET enabled, there will be many benefits. Single sign-on is probably the easiest thing for people to understand. But imagine if my calendars are .NET enabled, and so that when I went to a site and they wanted to schedule an appointment, they had the ability to drop something onto my calendar. If other sites were .NET enabled and I could, as an end user, start integrating that information. If I went to a site and instead of me filling in all the forms manually, if it could talk to my machine and find out about the information I had available, or to other computers out there that had my information and it could start stitching that together, then I think people will see a lot of end user benefits. But I think initially the benefits are primarily going to be to the developers. So as the developer wants to go build their application, instead of having to install, manage, maintain, and run each of the pieces of their solution, they'll be able to turn to other people out on the internet and bring those solutions together to solve problems.
So with the .NET providing this interaction between clients and servers and multiple servers and so forth like that, and the web being such a homogeneous or heterogeneous environment, what sort of problems are there involved in connecting to non-Microsoft platforms?
Well, so that's a great question. Let's kind of talk about how this thing would work. So you had this great analogy of a COM component, something like a VB control, and you would put it in your form. Well, let's kind of think about an analogy between that and the way you're going to do web services. So when you dropped a control onto your machine, you installed it. And one of the things that happened when you installed it is our software would look at it, it would reflect on it. It would look at the type lib and understand what functions were available for it. And then it would display those functions so that we could do things like statement completion, and it would integrate those things up and package them, and you'd have your solution. Well, we're going to want to do the same thing on the web now, but those things could be running on different kinds of machines, different kinds of architectures. So at the PDC, we gave people something called the Blue Book. And the Blue Book is a set of specifications that describe SOAP. So it describes the SOAP mechanism, the SOAP contract language, SCL, and the SOAP discovery mechanism. So together, those things are the Blue Book. And if you went up to someone's website that implemented those things, you don't really need to know how it's implemented. As long as those protocols operate, you'd be able to hook that thing up. In the same way that you didn't know whether a component was written in C++ or VB, as long as it gave you the right feedback, you were able to integrate that component into your app.
So you mentioned this Blue Book. Is that something that our audience can get a hold of?
Yeah, I believe that's out on msdn.microsoft.com. Look up the Blue Book. You can also go to the W3C website and look up the SOAP submission. That describes the way this stuff works. And there's a lot of companies out there supporting it in all kinds of different platforms. So on Java, using Microsoft technologies based on our v6 deliverables. And then we have a really great new offering, the .NET Framework, which is in our latest v7 versions of our products. So Visual Studio.net supports these things.
Okay, I'll take and I'll get a link to you from you for where the Blue Book's at, and I'll put that at the bottom of the transcript window. So you can just kind of scroll to the bottom of the transcript and find the link to the Blue Book.
That
so
sounds
get
great.
Information.
So let's just say that we want to actually go do this and we want to hook up our website. Well, what's going to happen? Well, it's a pretty simple protocol. The first thing that's going to happen is that my website wants to talk to your website. So what I'm going to do is I'm going to do an HTTP request to you, and I'm just going to get your home page. And if I looked inside the home page, just like you see style sheet links, there's going to be a link to something that's type is SCL. And so all we're going to do is we're going to follow that link. So we're going to just do another HTTP request to your site, and we're going to bring down an XML document on a SOAP contract language document that describes the entry points to your site, so what you can call, and the order in which you might want to call those things.
This document is in XML format.
Yeah, it just comes back as an XML document.
So SOAP is the protocol or the
Well, we're not yet down to SOAP yet.
Okay.
So all we did was we discovered what's available, and the way we do that is we go to your home page and we look for the link to the contract language. Then we bring that contract language down, and that's analogous to that type lib. And what it does is it tells us what the entry points into your site are. Now, when I want to call those things, that's when I use SOAP. And SOAP is a way to send an XML message through HTTP and get back XML. And I said through HTTP because that's the typical way things will work. But all of these things are based on open web protocols. And so if those protocols get better, for example, if we have some new high performance way to do binary encodings on XML, we should be able to easily pick that thing up. Or if you wanted to use another transport like MSMQ to send those SOAP messages, you absolutely could do that as well. So it's pretty protocol agnostic, but the common way we think people will do that, just because there's so much web infrastructure out there, is over standard web protocols.
Plus it gets past firewalls and stuff like that, so you need to worry about
and
that.
That's great.
Yeah.
Okay, so what I've done in my tool is we've enabled it so that if I type in, say, www.yourcompany.com, our tool will do that automatically, just like when we installed a component. So we have a new thing called the Server Explorer. You just type in the URL, and it will show you the entry points. And what it's doing is it's just doing those two requests and bringing the contract language over. And what it does is it automatically builds for us the right proxies so that when we make the call on the client, we get statement completion and all those other nice things, and they're making those calls over the web using standard protocols. And just like we were talking about, those things could be built in different languages. Well, here those solutions could be built in many different ways. So I mentioned people are building solutions in Java. IBM has a WebSphere product that supports SOAP. As long as they expose SOAP methods, the SOAP contract language, and discovery, all of our Visual Studio.net, all of our .NET platform products will be able to reach out and discover those things and integrate them. So we can certainly consume them. But what I think is pretty interesting is that they can also consume our stuff. So we're going to compete with folks by building really great implementations. We're going to have a great .NET framework, a great set of tools, a great set of servers, and a great set of services that are all built around this web service model.
So just the same way that HTML is a client-server agnostic way of rendering documents, this is just delivering that same sort of thing. I mean, like web browsers today aren't penalized because they're not working on a Next system, which is what it was originally developed on, but you can have Windows or Macintosh or Apache or whatever
Exactly.
you're connecting up to. So as long as the server, the web server that is providing a service, exposes their requested protocol in this SOAP style format, anybody else, any client, any server, can reach over, grab that information, and find out how to post these requests for additional data.
Exactly right. So we think that openness is going to be very important to people because we think that there's going to be lots of innovation going on a lot of different platforms, and you don't necessarily want to always have to rev your software. You may have an application or a service up and running, and you can then adjust other pieces of your application. So you get a much more loosely coupled way to build your apps, which we think can lead to a lot more productivity. So there's another aspect of loosely coupled, though, that I think is probably important for your listeners to understand, and that's that the web architecture is very scalable, and it's scalable because there's a lot of clever things that go on behind the scenes, and we're able to take advantage of all that stuff. So let me give you a couple of quick examples. When I go into a browser and I type www.yourcompany.com, two things happen. The first thing that happens is we go look that thing up in DNS, and that gives us back an IP address, and then we take that IP address and we go talk to the machine. At both of those levels, there can be indirection. So for example, when we go look that thing up in DNS, it could send us to a data center on the West Coast or a data center on the East Coast. So we get a kind of geo-scalability in the solution. Once I'm going to that data center, I have this IP address for the solution. Well, I could have something like Cisco Local Director or the Windows Load Balancing Service send me to a different machine so that I can scale that solution out. Well, guess what? Those same approaches to scalability, the ability to distribute the load across a bunch of replicated front ends, to do things like the data partitioning on the back end that gets me to massive internet scale, well, now I can use that at every level in my architecture because we're again using those SOAP level capabilities over those web infrastructure to get that to happen. So we think that that's a pretty compelling aspect of the whole .NET solution.
Now, I know one of the ways that sites distribute their load across things is using various ways to manage a session state. You know, noticing that this person coming at them is the same person that came before, thereby affinity them to the same server they were on before, so they don't have to fetch the data from some other database and do that cross thing. Does that same session-based affinity also work with the SOAP protocols?
Well, so let's just go into that just a little bit. I mean, when you design your solution, you really want it to be stateless in the sense that there may be an affinity to a server, but if I happened for some reason, because of Cisco Local Director or something else, to go to some other server, everything I need in order to get the solution to happen correctly is actually encoded in the cookies or on the URL as part of the message that goes to that front-end box. So the design is one of fully stateless activity. Now, I can take advantage of the fact that I'm likely to come back and cache things locally, but my design should support hitting any one of these things.
Would you be penalized if your design just flatly can't address a stateless model?
I think that you're doing yourself a disservice when you build that app because you're not going to get the highest level of scalability. But there's nothing inherent in the .NET framework that mandates that you have the fully stateless model. The great thing about our tools and our frameworks and everything is that it makes it almost trivially easy to go build these things. So you go in, you type in your function, it's automatically built in such a way that the appropriate round trips, the session states, all those things are handled in this stateless manner for you.
Okay. What are some of the key things that you're noticing people having trouble grasping about .NET and how it applies to their model of doing business?
Well, I think probably there's a couple of things that invariably come up. One is people kind of look at the web architecture and they look at .NET, and as they try and understand what's different, the key thing is thinking about services as a way to get more done for your developer hour. That you can go out, reach across the internet, and get that solution for you. Once they understand that, then the immediate next question is, okay, so what's the business model? Like, how does that all work? And then two, well, if every page has to go out and make all these requests to these other servers, won't my application be really slow? And so the first question on business model, let me just talk about that for a second. In the same way that you've got suppliers for any kind of business today, what happens if a supplier goes down? You go to some sort of alternate supplier. So you have to think about those kind of relationships when you're building your solution. If you've got someone supplying content to your solution, you probably want to have alternative ways to get that information in the event that they're down. So there's going to be many different approaches that people use. Some people will cache information. Some people will have alternative suppliers. Some people will just make very sure that their suppliers have very good reliability by maybe having service level agreements with them. So there's many different ways that people are going to approach the business model part of the equation. And I don't think we have an answer per se at Microsoft. It's the community as a whole is going to go out and figure these things out. And I think it's just like when people started first building package software or people started doing the web. Nobody really knew what the solutions were going to be, but there's a ton of really smart people out there, watching the show today. They're going to be the folks who figure that stuff out. And they should come to us and ask us about the infrastructure that they need. We'll do that. Other vendors will do that. But I think it's going to be a pretty organic thing about the business models.
So we're not defining the businesses. We're simply enabling people to define their own businesses.
Exactly. And I think that they're going to have just the same kind of challenges that they've always had. If Visa's down and can't process your credit card, what do? People come up with ways to handle that inside their businesses. Now, the second question, which is, how am I going to handle a request that comes into my page if I'm going to have to handle all these requests to the back end? And again, I think that we're going to see a lot of different solutions. One of the approaches is to make those things happen asynchronously. So, for example, you might make requests out of band. So if you're doing a stock market page, you might have the stock market information coming in from your supplier. You might aggregate that into a local database, and then as your page requests come in, display that. But that's still using a .NET architecture on the back end to go do the information. You might, just like we talked about in the previous example, have a service level agreement where you work with your supplier to have very high performance connections so that you can get that information done in a timely way and display that information to your customers. So as customers start thinking about how they're going to integrate all these other vendors to give their customers a solution, then people seem to get pretty excited about it. Like, oh, I get it. You're providing the infrastructure and some approaches to get the solution done, not the one way to go do this kind of thing.
And I suppose not to scare off some of the potential service providers there, but let's say you had a site and you had a service contract with some service provider providing the Visa model, stuff like that, and that service provider just started not having good service. Their servers are down all the time. There was a slow connection. Because of this .NET architecture, it wouldn't really cost you as the consumer, the site that was consuming the services, that much trouble to switch to some other service provider?
Well, I think that one of the ways that vendors will differentiate themselves is they're going to have a lot of cool stuff running in that solution. What we're going to do is we're going to raise the level. So instead of you having to worry about how do I encode the bits over the wire, what you want to do is you want to think about how your service is much better than the other guy's service in terms of real value to your customers. The value is not going to be as much in kind of the lowest level plumbing, how you connect those things up. And if that's the way you think you've got a lock on your customers, then I think you've got some stuff to worry about, because that's not really helping your customers. Your developers want to have easy solutions at that level, and they want to take advantage of what you really bring to the table.
Mm-hmm. Okay, thanks. Now, before we wrap things up here, are there any key concepts about .NET that you think is really important for the audience to grasp?
Well, I'd just love to walk through kind of the main differentiations about .NET. So we talked about the open internet protocols. I don't think we need to say too much else there. I think it's worth pointing out that Microsoft is going to be taking all of our server products, things like SQL and Exchange, App Center, and we're going to .NET enable those things. And that means we're going to support these open internet protocols, things like SOAP, so you'll be able to call them. And over time, they're going to become all programmable with the .NET framework. In terms of our services, we're going to be doing the same thing. So the things that Microsoft runs, things like Passport, our calendaring services, our storage services, those things will become .NET enabled and programmable. The other key thing is we're going to have our services and our servers over time be able to work together better, to be able to be federated and to use common models.
But federated, what do you mean by federated?
So a federated, let's take email as an example. Well, you can use Hotmail out on the web, and let's say it's fully SOAP and web service enabled. Well, I might want to use those same models against my local Exchange system. You could think of Exchange and Hotmail, when they use the same web service model, as being different levels of capability. And you'd want those things to talk to each other. So one's kind of the corporate accelerator and one's a general mass market solution. When they work together well, you can think of those things as being federated together. So we've got a set of federated servers and services. We want people to think about taking their apps and making them .NET enabled, turning them into services so that other people can use them. And when you do all of these things, you get increases in productivity, you get the ability to more easily integrate with other folks' stuff. But I think there's other kinds of interesting opportunities. For example, on the UI side of the house, what you'd be able to do is, clearly we're going to let you project HTML out and support cell phones and all that kind of stuff. But imagine that you have much smarter clients. They'll be able to use the web service that you provide to start putting together solutions in ways that maybe you as a developer didn't even think about. So when Excel or Word becomes programmable, people inside of corporations use that programmability to build solutions for their internal customers. I think you'll start seeing the same kind of thing. So .NET gives us the ability to produce those much more capable custom solutions, to integrate other folks' stuff, to leverage other technologies that are running out on the web to be more productive, to integrate with other solutions. So I think that there's a lot of pieces to .NET, and hopefully this has given your audience a kind of top-level understanding of some of those things.
Well, thanks, John. I appreciate you spending the time with us to share with us your thoughts as the .NET architect, what .NET means to the future of programming on the web, whether it's on a Microsoft Windows platform or integrating with some other platform out there on the web, which the internet is so great at incorporating. So that covers the architecture of what the .NET framework provides to you. Now, after this short break, we'll come back and talk with Mark Anders to try to dive in further on some of the programmability capabilities and what you as programmers need to start thinking about in order to enable your applications and solutions to use the .NET architecture.
Hi. I'm not a monopolist or even a bully. I believe in fair and aggressive competition, not government intervention. I don't live on the lake or eat pizza every day or even drive a Porsche. I have an open door, not a penthouse office suite. I talk to customers every day, and I even read my own email. I believe in innovation, not interference, appreciation, and not arrogance. And I think every executive should play hockey and not golf. Microsoft is the greatest software company in the world, Because we have dedicated employees who create and sell the greatest damn products in the world. I'm Brian, and I work at Microsoft. Yay! Thank you.
The .NET framework is more than just a bunch of high-level overview thoughts and concepts of servers and services and web pages and stuff like that, because at some point in time, you've actually got to write code. Now, to help us understand the issues that a programmer is going to face in writing code for the .NET framework, we have with us here Mark Anders. Mark's a product unit manager for the .NET framework. Thanks for joining us, Mark.
Thank you.
So, in a programmer's perspective, what does the .NET framework actually bring to the table?
Well, what the .NET framework really brings to the table is that it makes it, number one, easier for you to write your code. It frees you up from the plumbing that you had to write in the past. And it also gives you a consistent way of writing applications that take advantage of Windows, that integrate with web services, that expose web services, or that are web-based applications. So you have sort of a consistent, very, very much easier to understand, far less code than you had to write in the past way of building applications.
And by easier, what exactly do you mean? What was harder in the past, and how are you making that easier with the .NET?
Well, in the past, there were really a couple of things that, depending on the type of application that you were writing, that made it difficult. If you look at how we defined APIs in the past, there were really a bunch of different ways that you could access the system. For example, we would have the Win32 APIs, which were a set of low-level function calls with some data types like an hwind, or a handle to a brush, or something like that. And that was one level of the system. Then, depending on the language, there were different frameworks that were built up to provide an abstraction that programmers typically program to. So, for example, if you were a VB developer, you thought in terms of rapid application development with controls and event handling. If you were a C++ developer, you thought in terms of something like MFC with inheritance and very C++ oriented way of building Windows applications.
So then the whole thing with .NET is it takes all these different models and different approaches to writing applications,
right,
and simplifies everything?
Well, what it does is, number one, it simplifies it. So if you think about the COM programming and the type of way that you programmed COM in terms of implementing a variety of interfaces, in terms of managing the lifetime of objects, we've simplified that so that you don't have to think about the plumbing anymore. And we've also enabled it so that across all of the different languages, there's a single consistent way that you access these system services.
So you mean like if I was a VB programmer doing new .NET VB programming, and I looked at some C code or some ASP code, I could actually recognize what they were doing a lot easier? It'd be almost the same sort of language format, you mean, or what?
Yes, exactly. So the layers of the system are, we've got the .NET framework, which is sort of the programming constructs that you use. So whether you're in VB or C++ or C#, which is the new language that we've introduced, the programming framework that you use is the same. So when you create a window in one, it's a window in all of the others. And you can mix the code between all of those different languages.
Yeah, because I remember, like, and when I first got started, I was doing Win32 programming, and then
Right.
when Visual Basic came out, looked how they did it. I mean, everything was different.
Right.
I mean, I didn't have a message loop in Visual Basic anymore. I didn't have a create window call. I didn't have to do that anymore. So all the things that I learned to do for Windows programming in Win32 was basically thrown out the window when I had to do VB programming, and then with ASP programming, it was a whole new ball of wax for that sort of stuff. So you're saying the .NET framework creates an abstraction layer of what the system provides that's the same for all those people?
That's true. There were these different layers that you programmed at. But the fundamental thing about .NET is to really pop up a level. So what we have done is we've simplified it and made it consistent across all the different types of applications that you've written. But The big focus for .NET is really this next generation of web applications and services that we enable. And we also enable you to build Windows applications, but we've made it so that the programming experience is really consistent across all those different types of applications and services. So why don't I actually show you some code of how we would build, for example, a web application using the .NET framework and ASP+, which is a part of the .NET framework.
Sounds like a good idea.
Cool. So this is just some very simple HTML that we have here, right? And the thing about the web programming model has always been that it's a stateless programming model, right? You have HTML that gets sent down to a browser. You've got something like ASP, which is all about script code. And so if we look at, if we take this HTML page, has a simple form, right, with an input box. Let's take a look at that in the browser. This is that page, right? And you'll notice if I do something like, key in my name and select deception. And what I'm doing here is I'll build up an application that's selling spy equipment. That's why the categories are kind of a little unusual. And if I click lookup, what I get back is just the same thing I started out with, right? Because it's just HTML. I'm posting back to that page. And if we look at how we would do something with that page, for example, grab the values that I entered and display a message to the user, and then also you'd probably like it so that you didn't lose the values from the edit box and the drop down. If you look at how we would do that using our existing methodologies, it would look something like this. And
so
this is
ASP code on the server that is then extracting the data, pushing it back into the form again.
Yeah, the key point of what was happening was that in order for anything to happen, you have to write code to make it happen, right? HTML has no built-in functionality to like display a message or maintain the values. It's all just
documented.
It's just a document, right? And you play games with having server-side logic that generates the right stuff to give you the user experience that you want. And it means that you have to write a lot of code. So here, let me show you that page, show you what it does. If I type in my name and I say that I like travel, you'll notice it says, hello, Mark, you selected travel, and it maintains the values, right? And the way that I did that in ASP code is I had to write code for every little thing that I wanted to happen, right? So when I'm outputting the input, I have to, grab the name from the request that came in, the HTTP request, and shove that in the input field to say this is its value, right? Doing the select, I had to write quite a bit more code. Right, I had to say, is the particular option that the user sent me the option that I'm spitting out? If so, I label that as selected. And to actually spit out the message, I just plop a little if statement in there that says hello, whatever the name was, and that's the style of ASP code that you wrote. And it's actually very easy for people, right? You just save that file on the file system, and the system automatically compiles it when you request it with a web page. And so it's pretty straightforward, but there's a lot of code that you have to write. And also, if you go back to that VB example that you were talking about in terms of VB forms and not thinking about message loops, you just thought of a form and you thought of event handling, right? You thought about the controls that you were going to use and what you wanted it to accomplish. And so if you were a VB developer who went to web development, you would say, well, what is all this stuff? Well, the language might be the same, right? You could use VB script in there, and that's pretty similar. But the programming techniques that you used were very, very different. And if you were a C++ developer, I wouldn't be able to write ASP at all, right? Because it was script languages. So I would have to write at the ISAPI level and do a lot of low-level code. And so what we've really tried to do with the .NET framework is, first of all, raise the level of abstraction, right? So that if you're a C++ developer or a Visual Basic developer, you have a really consistent way of viewing the entire system. And also to take the programming model and make it so that whether you're programming a Windows client or you're programming the web, you have it feels the same. You have the same programming constructs.
So you're programming a Windows application the same way you'd program a web page?
Well, actually, it's kind of the reverse. It's more that we take the techniques that we've used to really simplify Windows development and apply them to web development. So if you think about writing at the Win32 level, it's pretty low-level code. You've got a WinProc and you've got a message loop, and you think about all of that. The frameworks that were built that people typically target, such as VB, such as MFC, are higher-level constructs where a lot of the details of how that happens, how you interact with the message loop, how events come in,
are being handled for you by the
yes,
underlying OS.
right. There's the message map in MFC, and there's some mechanism in the VB form that dispatches,
hides it from you totally,
that
yeah.
hides it from
Yeah.
you. Now, with a good framework, though, you can actually drill down, and if you need to get at that lower level, you can. So let's take a look at how you would build this same page in ASP+. So if you think about Windows and what we've done with VB, you had this notion of controls that had properties, methods, and events, and you would interact with those controls. So what we've done with ASP Plus is that we have taken those same concepts and applied it to web development. So we have the concept of a server control, and what that is it's an object that runs on the server. It's a control that runs on the server and that I can program against. And it performs the same function in a web app that it does in a Windows application, which is that it displays the UI to the user, it generates the UI, and it also interacts with the user. So as they interact, as they click on a button, that control, for example, that is the button control, can handle that and then raise events. Now, the way that we represent it, this probably still sounds a little mysterious, a server control, what is that? But really what it is it's a tag. It's represented by a tag with an attribute run at equals server. So what a server control is a control that runs on the server, and it's represented by a tag with an attribute of run at equals server. So I can simply go up to that input and add this run at equals server attribute.
Yeah, that's the same like in scripting code. In my
Yeah.
scripting, I can say script run at equals server, and that's server-side script.
Exactly. That was one of the techniques that you used in ASP to denote server-side code. And so we took the same technique and applied it to tags. And when the ASP Plus compiler sees that, what it does is it says, instead of having this tag and spitting that out to the client, I will instantiate this control that's responsible for generating the UI that goes down to the client to represent that input tag, for example. And it will also do some other stuff for us. So let me now switch to a page where I've added run at server to all of the different tags that we want active on this page. And as you can see, I haven't written any code. I've just added this one attribute, right? In a similar manner to how I would possibly build a VB form, right? I drag a bunch of controls. I haven't written any event handlers. But now if I run it, so I'll save that. And switch to this. And so now if I run that and say deception, you'll notice when I request it, the values are maintained in the various controls, right? Because the controls can interact with the action of posting back, and they can understand, for example, the values that I as a user have input.
So then what was happening there is that you were having input code, input tags being stuck on your client-side page that came down to your client. You hit the submit button, then when that posted back to its own self, you had server-side code that was being run just because you said run at server, that each input item grabbed its value out of the incoming item and reiterated itself back out to the client page again.
Yes, exactly. So the way the model works is exactly that. We compile the page down to it's actually an object that is the page and all of its controls that run on it. And we instantiate it to handle the incoming request. It looks to see if any values have come back from the client. Each control can take part in the request processing. So the input control can look and say, for example, did my value come back? And if so, I can grab that and make that available. And then when I regenerate the page, it can spit out the proper value. Now, the other thing that you can do is that you can actually, from a programming standpoint, write code that interacts with those controls. So if we go and take a look at how we would program against this, in VB what I would do is I would write a little event handling code to say when the button is clicked on, I would like my code to get called, and we could do the same thing. So where we would, the first thing we'd do is we'd probably place a label control on the form, right? And I can do sort of the equivalent thing in ASP+, and I'll add a little label, which in this case is an HTML span, also with that run at server attribute. And you'll notice that I have an ID, which is the programmatic identifier that I use to address the code, address the control from code. So I can then drag a little event handler, and here I'm using Visual Basic code. And one of the key differences about ASP Plus versus ASP is that we can support all of the different languages that target the .NET framework. So we can use Visual Basic, full Visual Basic, not VB script. We can use C# as a language. So in the past, ASP has also been about, if you wanted the ASP developer experience, you used script languages, and they were loosely bound, and you didn't have all the features that you had in VB. Here you have actually the full VB language, and it's actually compiled. It compiles down to native code, so it's much, much faster. And so here's a little event handling function, and what I'm doing in it is simply going out to the controls. So I go out to the input, which is the ID name, and I go out to the select. I retrieve their values, and then I set the inner HTML of the span, which is my little label, to be equal to the message.
And the inner HTML, that's the same property I'd use in dynamic HTML on the client using Internet Explorer to expose this, but I'm doing it on the server rather than on the client browser.
Exactly. Now the key thing to note there is that we do not have the full DHTML object model. It's not really DHTML. It's something that's tailored at the server and has a slightly different object model. Where possible, we've kept it the same. So if it's a span control, if it's a span, you actually have inner HTML and the same properties. We've tried to keep the properties the same so that you can leverage that knowledge. But it is slightly different. And so the last thing I can do is I have to tell it, the system, that I want my method to be called when I click on the button. So I add a little event binding property to the button that says, for your on-server click event, and on-server click as opposed to on-click, which is the client-side click event, call the submit button click. And so if I save that, and then re-request this page, it'll say, hi Mark, you selected deception. And if we look at the HTML code that was generated, you know, the client side, if we do a view source, you'll notice I don't get any of the server side code that I input, and I don't see run it server. It's simply HTML. Now, one of the things you'll notice is that there is a hidden field here. And even though we have a model that feels very much like VB on the server, or C++, with something like MFC, the programming model is actually stateless. So even though it feels stateful on the server, it's actually stateless in that after you finish generating a page, we destroy the instance of the classes that generated that page. And that means that if you're scaling your application in a web farm, you can have multiple machines and the request can come into any machine. What happens is all of the controls, if they need to store state between one invocation and another, can do so, and it's actually sent to the client.
So it can be a stateless application to an extent, but still have a stateful feeling to it.
Exactly. The programming model is stateful. And if you think really about what people do on the web today, they play games to get around the fact that it's stateless, that there is no state that's really held on the server, because with a web application model, you want things to be stateless. So this gives you a view of how we've made server-side web programming similar to VB. And it's actually a much richer architecture. I'd love to come back sometime and show you more about the power of that. But the other thing that we've done is we've made it so that writing applications of any type, accessing system resources of any type, is much, much simpler. So that in the same way that I just simplified a bunch of ASP code with ASP Plus code, we can also use the .NET framework to simplify doing things like writing to the NT event log.
Standard Win32 stuff.
Standard Win32 stuff. So I can show you a little code here. So if I if I wanted to write something to the NT event log, this actually came from MSDN. We went there to figure out how to do this for a little sample. There's a lot of code that you have to write. You have to register event sources. You've got to do things with the account. You've got to then, finally write something to the event log.
And doing stuff with the event log is actually something that's fairly important, and we recommend applications that should be doing this to definitely make sure they do it, because it allows the systems to work well, for the administrators to find out what's going on and notice how to tune their systems properly. So this is very important code to do, and yet it's also difficult to do.
Right, exactly. And this, unfortunately, is kind of typical of a lot of the stuff that we've had in the platform. A lot of the things that you'd like to be very easy to do require a lot of code. So,
and one of the problems being difficult, I would expect, also means that quite often people do one of those steps slightly wrong, and it ends up causing a problem or a bug in their application.
I mean, for every couple of lines of code you write, you could introduce a bug. And if you have to write 20 lines of code, you have 20 opportunities to introduce a bug. If we take a look at how you would write the same thing in the .NET framework, this is it.
It's a lot less code.
It's a lot less code. And the other thing is that you can go up to this after it's been written. It's not only a lot of less code to write, but if you're somebody who's maintaining a site, an application, you can go up to that and look at it, and it's very, very straightforward.
You're just creating an event log object and accessing.
Exactly.
Now, I noticed this is also using C#.
Right. This is using C#, which is a new language that we've created that takes the power and expressiveness of C++, but makes it much simpler. And it also works with the new Common Language Runtime, which is really the lowest level of the .NET framework, and really what all of this stuff is built on.
Now, what exactly is the Common Language Runtime?
What the Common Language Runtime does is it takes care of all of the plumbing that you would normally write. So if you know COM and you would think about IUnknown, implementing IUnknown for discovering what interfaces you have, and doing addref release for managing the lifetime of your objects. And if you wanted to, for example, be usable by a VB client, you would use automation, so you would implement iDispatch. The Common Language Runtime is the thing that takes care of all of that for you.
And is it kind of like then MFC or ATL, or?
Well, it's kind of, it's more like how a language represents a class and an object, and fundamental. ATL, MFC is really a framework built in C++ for doing a certain type of application. ATL is really a framework for, in C++, doing COM. The runtime is really the way that any language, whether it's VB, C#, JavaScript, COBOL, can have an object system and a type system that is common across all of those languages. And it gives you lots of, it simplifies the code that you have to write. It makes it so that you have many more powerful features, such as language inheritance, right? I can now actually use implementation inheritance, so I can just say I'd like to extend this object and override a method or add a new property. And the cool thing about it is that it's common across all the different languages, so that an object in one language is an object in another language. So if I'm in VB and I create an object and it has some properties, methods, and events, and I go into C#, I can see that object as if it was a natural C# object. I wouldn't know that it's any different.
Now, does the language itself have to uniquely support the notion of objects? What if I had a language like Forth or something like that that doesn't really understand objects? Could I use the common language runtime with that? Would I have to enhance the language to support objects?
Well,
I guess not that people are writing in Forth anymore, but I
well,
used to.
there are actually a lot of languages that are targeting the .NET framework in the Common Language Runtime. Things like APL, which is another language that you don't hear many people writing in, but there are actually communities where people do. There are a variety of different levels that you can support the Common Language Runtime.
What's the benefit then of having a common language runtime that can allow, APL or PL1 or Forth or things like that to still be used?
Well, the real benefit is, as we've gone around to customers who use different types of languages and find out why they use them, typically it's because those languages allow them to express the concepts that they're trying to express more concisely and be more productive than other languages. So if you go to Wall Street, for example, they might use specialized mathematical languages like an APL or a Maple
or Fortran or something like that.
Fortran. And they do it because it has unique attributes that make them more productive. And if you look at why Visual Basic has been popular or why C++ has been popular, it's typically because the languages have a certain expressive power, a certain way of expressing syntax and certain facilities that make it more productive and easier for people to understand.
So then with C# kind of being a language that we're describing as being well-tuned for the .NET framework, we're not necessarily trying to say everyone needs to rewrite like applications for C#.
Oh, absolutely, absolutely not. We've also modernized VB quite a bit to give it a lot. So now in VB.NET, you have things like inheritance, you have exception handling, so we've actually taken all of the languages that we produce and made it, VB is as good as C#. C# was to take sort of the C programmer, the C++ programmer, and give them a more productive language with a syntax that's familiar. But it doesn't mean that everybody has to write in C#. In fact, the whole reason that we've invested in a multi-language platform is to say that people are, have very real reasons for using multiple languages.
Mm-hmm. Now, when I was talking with John earlier, and he was talking about the whole notion of services on the web and client-server interaction and SOAP and exposing your methods and protocols in that fashion, it seemed very much like .NET was being this big network connectivity platform, where so far we're talking about is individual granular bits and pieces, whether it's the common language runtime or whether it's this run at server stuff with ASP+, or whether it's C#. And individually, when I look at all those different pieces, I'm not necessarily seeing this internet connectivity model.
Right, we haven't seen anything about web services.
Yeah.
Well, the .NET framework actually provides a very, very simple way to create and consume web services, and I can actually quickly show you how you build one of those.
Sure,
as well. And I realize we're getting sort of to the end here, so I'll have to make this quick. So this will be the fastest web service you've ever seen. What we've done is we've created, in the same way that ASP created a model for building HTML pages, where you write some HTML and you add code. We have a similar model for web services, but the model is really that you write classes and deal with data, and we map in incoming HTTP requests with SOAP or HTTP GETs or form posts into method invocations, and we hide the fact. We make it so that you don't have to think about the XML or how the data came in. You get to think about the data that you want to deal with and the data that you want to return. So, for example, the first thing I would do is we have a new type of page, which is an ASMX page. And the first thing I'm going to do is define a class, right? And what we're using here is C#, and we have a little declaration that just tells the ASP+ runtime that we're programming in C#. And now if I go and request that page, by hitting that URL, we dynamically compile it, and because we realized that it detected that we're hitting it with a web browser that is not invoking a web service, it actually generated a little HTML help page that gives us information that this is a URL that's really a web service, and it gives us the name of the web service.
So almost like self-documenting?
Exactly. It gives you a little documentation page and allows us to see what the contract is, the SCL contract. And if I request that, it will return the XML that describes what my web service does. Since we actually haven't added any methods to the class, it doesn't actually do anything at this point. It doesn't say much, but it has sort of the outer wrappings. So now if I go and add a method, for example, a method to take two numbers and add them together and return them, I can simply add that. Now, a couple of things to note. One, there's no XML here, right? My business logic in this case, although it's not very proprietary or valuable, is adding numbers, right? So I think of just taking
You're going to make an awful lot of money on the web like that.
Yes, exactly. I guess I won't quit my day job anytime soon. So I'm just taking two numbers and I'm thinking of adding them together and returning them. And so that's how I've written my method. I don't have to think about HTTP or XML. I think in the data types that I naturally think in, and the web service programming abstraction takes care of all the details. So if I simply save that and refresh this page, you'll notice that the HTML documentation page got a lot richer.
It did.
And it tells me that I now have an add method, and it tells me the parameters. And if I go and view the contract now, you'll notice that too has gotten much richer. So we take care of all of the mapping of how you take data types and map them into XML, and how you take services and expose them, and the plumbing. You know, again, it's this theme of getting rid of the plumbing, so you don't have to think about how do I take this class and generate the sort of the type library for the internet, the IDLE for the. I just think of writing the class.
Yeah, you just wrote the C# code for the class.
Exactly, and I can even invoke this thing, so I can go down here and it allows you to use the HTML form invocation model, and I can feed in 1 + 1 = and I get back in XML 2.
Well, maybe you will make some money on that. It actually works.
Well, it does work, but that's probably not the type of thing that I would really expose. But I might take, for example, more complex data types like a record set from SQL Server. I might go out. You might ask me for products of a particular category, and I might go out to SQL Server, query the database, and return them. And I can very, very easily add that type of functionality. So, for example, I can import the classes that allow me to interact with data. So the data classes and the SQL Server provider. And then I can just add a method that takes an integer, which is the category, and creates a new connection to SQL Server, gives it the name of the server, does the query, and you can sort of scroll over here, select star from, from products where the category ID equals the category, and then does the query, and then just returns the data set. So again, I'm dealing with sort of a complex data type, but I don't have to think about XML and how my data type gets converted into XML.
There's not even any HTML in that code either.
And there's no HTML in this code either, because it's really all about XML. And so now if I come back and then go to the get products method and invoke that, we've dynamically recompiled the class and invoked it, and here's the data that got returned from SQL Server.
All is an XML string. You can then do with as you wish, pass it on to someone else.
Exactly.
Or whatever.
Exactly.
So that's the way that a application programmer could take a standard programming logic that he's doing without even doing any HTML or XML or anything like that at all. Stick it on his server, expose the properties, methods, and events using the SEL, and you as a web programmer now could reach out and touch his website, see what his properties, methods, events are that he's exposing as a service, access those services, get the results back, and do whatever you want with it.
Right. And the final piece of this is that we've built this platform that enables you to, build these web applications and services. We also have the infrastructure to allow you to consume them. So from a consumer of a web service, I can naturally go out and call these things, as natural as making method calls. So again, I don't have to think about XML. I can just think about the fact that I want to invoke the get products web service, and I can make a method call and get back the data, and it looks like data to me. But finally, we've created also the tools to enable you to be very productive in building these types of applications. So in visualstudio.net, you'll be able to, just like adding references to COM components, add a reference to a website, a web service, and you'll view that thing as if it was a real live object.
With autocomplete and
with
all that
exactly
stuff.
Statement completion, and it makes it very, very easy. And we've also built in things like asynchronous programming into the model, so that if you want to make sure, since you are going out over the internet with a method call, you can do it in a very performant manner.
Well, I can tell that the .NET framework sure includes an awful lot of stuff, and I expect that what we'll end up doing is to have several episodes now talking about various aspects of the .NET framework and C# and ASP Plus and SOAP, and I hope you're willing to come back for at least one of those at some point in time to,
yes, I
to
definitely
further
am.
dive into things.
It typically takes, we just completed the PDC and we had 3 days of drill down into all of this, and it's really hard to get across all of the different stuff that we've done in just 30 minutes. But the key things to take away are, number one, that we've made it simple to develop. We remove a lot of the plumbing that you have to write. Number two is we've given you a consistent programming interface to all of the different types of things that you do, whether it's building a web application, building a web service, accessing the event log, building a Windows application. You can move across those different domains and you still have a very consistent view. You have the very similar design patterns. You have common collection classes, common component models, common ways that a property or an event comes into your code. And the third thing is that we've really embodied the internet as a programming infrastructure. Maybe embodied isn't the word. We've completely based the platform, adopting web standards and practices where we can. So if you're building a distributed application, the way you talk from one node to another is via this web services mechanism that uses HTTP and XML as the transport. And so it really opens up, we've provided a very simple, clean, consistent way of building really scalable applications, but also that interoperate with non-Microsoft systems, so that if you're the guy running an IBM mainframe and you want to get your data over, SOAP and HTTP are great ways to do that. There are, IBM, for example, is doing SOAP. They've authored it with us and submitted it to the W3C. And they're building
so we're not just talking Microsoft,
it's not just a
Windows.
Microsoft standard, no. It's an open standard supported by a number of different companies. And they're going to be building this into their systems as well. So it'll be very easy to make different types of systems talk to each other.
Which is kind of what the web's all about, it seems like.
Exactly.
Okay. Well, thanks a lot, Mark. I appreciate you taking the time to share with us these demos and insights about what .NET is and show us some real code so that the programmers out there in the audience can really understand what this means to them and how they can start grabbing their teeth into it. I suppose one thing that they should think about doing is trying to download that 86 megabyte download from the PDC release that we gave out, and playing around with that, 'cause that includes the Visual Studio 7, some of the common language runtime, the C# compiler, and some ASP Plus stuff. Is that right?
Well, it's a little different. The 86 megabyte download consists of the .NET framework, which is all of the programming framework. So it's the Common Language Runtime, it's ASP+, it's Windows Forms, it's all of the different programming frameworks. You've got command line compilers and the SDK level stuff. It does not include Visual Studio .NET. That will be released in Beta 1. This is really a preview. But in some ways, the most remarkable thing about the whole preview release for me was that, for example, the application that I was starting to build up, that spy website, was a site that we launched on the internet at the PDC called iBuySpy.com, and that's www.iBuySpy.com. And it's a site implemented in ASP Plus and the whole .NET framework. And, you know, being the guy who's in charge of the team that's building this, you know, we know where it is in the whole scheme of things. It hasn't reached beta, and so you put it on the internet and you get, you know, thousands of hits. If it had lasted an hour, you know, I would have said, well, you know, we have some work to do, but it's kind of to be expected. But it actually lasted over 50 days, received over 1 million hits. And we've designed the platform also to be incredibly robust and to understand that failures will happen and to be able to gracefully recover. And so after 50 days, it actually restarted itself. The server never crashed. The machine didn't have to reboot it. It just kind of migrated to a new process and kept the app running. And so it's still up and running. So it's been, at this point, coming up on a couple of months.
For a pre-beta preview release of something, that sounds pretty darn good.
Yeah. And there are also some other sites that are on the internet that people have already deployed with these preview bits, and I think they've been having a good experience with it. So.
Well, thanks, Mark. I appreciate you joining us.
Thank you.
So that hopefully addressed some of the issues about programming .NET. Now, like I mentioned, future episodes are going to dive deeper into some of these capabilities because I know we just scratched the surface. So be sure to pay attention to future episodes of the MSDN Show to find out more about the .NET architecture.
Last July, Microsoft released its 7.0 version of the Windows Media Player. And a huge team of people were involved in that media player, from program managers to designers to developers. And with me today is Nadja Volokes-Wilson. She is a user interface program manager for the Windows Media Player. Nadja, welcome.
Thank you.
Glad to have you here.
It's a pleasure to be here.
So tell me about your job. What is it like to be a user interface PM for the media player? What does that entail?
Oh, well, I started the job about a year ago. I was previously in a group called Developer Relations, where I was working with a lot of partners and teaching them about new technologies, including like cascading style sheets and helping them get their content ready for the web. And I got to a point where I realized there was some other interesting areas within the company that I would be interested in getting involved with. And one of the areas, a job came across my table, and they were actually sending me inquiry to see if I knew anybody for this position on the Windows Media Player team. And I looked at it and I was like, I think I can do that job.
Looks good.
And so I interviewed for it, and it went really well, and it was a perfect fit. And so for the last year, I've been working with a team that did the Windows Media Player. The player itself was basically kind of a redesign of the 6.4 media player. So we had a lot of new features that we had to work on, everything from skins to visualizations to burning or copying CD music to your computer. We had just a ton of features to work on, so it's been a really interesting project.
What are some of the new exciting features of 7.0 that you're particularly proud of or that you had fun working on?
I think one of the ones that was the most fun was the skins. That one I spent quite a bit of time on. I worked with lots of partners and also with skin designers that worked on the project as well. And we had a lot of fun brainstorming sessions. We came up with a lot of interesting concepts and interfaces that bring a lot of personality to the player. And so there was a lot of creative freedom that myself and other folks on the team really enjoyed. The visualizations are also really interesting because they're really dynamically different. When you play the music, they play along visually to the music, and you can do a lot of creative things with those. I think the other features just sort of speak for themselves. We had a lot of integrated content, so people could easily find music on the web through a media guide. There's basically copying CD music to your computer, so that enables you to capture and organize playlists and really get into your music collection that you might have. So it's really fun.
Yeah, the radio tuner, that's my favorite.
That's
new
another
feature.
good
I
one.
love that one. I
Yeah,
think
the
it's
radio tuner is fantastic. It really
incredible.
lets people get out and find radio stations from all over the world. I mean,
Yeah, and the
that's what
quality
makes it
is
really
incredible.
interesting. Yeah.
So tell me a little bit more about the skins. What does it take to design a skin? Is it easy for a developer at home or even a home user to design their own skins?
I would say that actually there's a couple resources that are really helpful to get you started. The first thing I would do is just take a look at the skins that are out there. You can unzip them using WinZip really easily and look at the source and what it takes to actually create a skin. So the skins themselves are great learning examples. For example, you can take one and look at all the graphics that are inside of the skin that make up the skin. You can look at the XML file that the skin is authored in, and then there's scripting files as well that you can just kind of dig into and take a look at.
So now that the 7.0 version has launched, give me an idea of what your day-to-day activities are working with the player now.
Now we're planning for the next version, so the features that I'm working on are just, heavy in the works right now and planning stages. In terms of, I can't really talk about what features are coming out. It'll be a surprise, but it's really mostly focused on designing the new features and improving some of the usability issues that we incurred in the last version of the player, because it was sort of a 1.0 project, and there's a lot of kinks that we want to work out and improve upon. So.
Right. And before you worked on the media player, you said you worked at DRG, and that was your first job at Microsoft, were you?
Yes, actually I started in developer relations about 4 years ago, and I was working with partners designing interactive television applications, and that was really interesting because I was able to not only design for the computer interface realm, but also bring that into the television space as well. So it's sort of a mix of designing graphics for a different resolution and a different screen and a different interface as well, because we had a little remote control, and it was fun to teach people about that experience. And then as the company progressed and worked towards the web, I got involved with that and helped other partners do IE4 channels and a lot of the cascading style sheet work. I worked a lot in that space as well.
So tell me a little bit about what you do outside of work. Do you do a lot of design work on your own projects?
Actually, that's a really good question. I do spend some time just kind of looking for other avenues of creativity. I think it's a really challenging job. We spend a lot of time here at Microsoft working, and to get a lot of influence, especially in the skin space, I always looked at nature and looked at other spaces to kind of get influence in the things that I create here that are sort of a combination of nature and technology and bringing those together. So bringing organic shapes and I don't know, natural repetitions, or just things that you see in nature, trying to bring that into the work that I do here. It's kind of rare. You can't really do much of that with some of the technologies, but there is, and with the skins you're able to do that in some way, because you can do a little bit of diverse creativity.
More of a creative outlet.
Yeah, so I guess I really like nature and being outside and appreciating what's going on visually outside in the natural world, and trying to bring that into the work that I create.
Right. Well, living in the Northwest, we have the great opportunity to go out in nature and go hiking.
Except it rains a lot, though.
Yes, that's true.
But that's also nice because I don't know, it's peaceful.
Do you spend a lot of time in the outdoors?
Yeah, actually, my husband and I just bought 45 acres out in the country, and we have a lot of work to do, but it's basically starting from scratch. But we want to plant a grape vineyard, and I'm really into gardening, so I'd like to really get into. There's a lot of work to get this foundation built, but I'd really like to build a French intensive garden that basically combines the methods of the way the French in the Provence and south of France, they build these like really intense gardens where they put herbs and plants and flowers and kind of all things all together into one space. Now,
you said your husband also works at Microsoft?
Yeah, he does. He's a group program manager over in the internet gaming. Well, actually, he's not in the internet gaming zone anymore. He's actually a group program manager for the role-playing adventure technology group. So what they do is create all the games that have to do with role-playing and technology and adventure. And so Asheron's Call was one of the games he worked on, and there's a lot of other new up-and-coming games that he's working on that'll be on the Xbox platform. So it's pretty exciting. He gets to play games all the time and call it research. So
Sure. You get to listen to music, he gets to play games.
Yeah, pretty rough.
So do you find that is it easier, or is it challenging to have both of you working at Microsoft?
Actually, I enjoy it. I think we both enjoy it. It's nice to have us working in different groups at Microsoft, because we both can, when we come home, we have stuff to discuss that are somewhat similar yet different.
Sure.
We can draw a lot of analogies from our day-to-day lives, and just working with people, and there's a lot of commonalities between our jobs, even though we're working on completely different software and technologies. So it's enjoyable. It makes it nice and gives us a lot to talk about.
Well, that's great. So you're busy at work at the next version.
Yeah, definitely busy and writing specifications
Right.
and figuring out, what we're going to deliver in the next product. We'll still probably, you'll be seeing a lot more skins coming out. So the website, the windowsmedia.com skins gallery has quite a few skins on it, and there'll continue to be more on that site. We have some partners that are doing some really interesting skins as well, so you'll start to see those.
Okay.
And
the Windows Media Developer Center, I think there's links to the SDK. People can
find
links to design and build their own skins.
Yes, and there's actually a book being written as well that'll be coming out. I'm not sure the timeline on it, but there is a book that will be coming out that tells people all about Windows Media Player 7 and how to author skins and how to do visualizations. And there's just lots of information in the book that will be coming out soon, so that's good.
Okay. Excellent. Well, thanks for taking the time to be here and talk with us.
Thank you.
Thank you.
It's good talking with you.
Thanks, Erica. Well, that brings us to the end of another episode of the MSDN Show. This time we covered an overview of the .NET architecture, hopefully helping you with information you need for your applications.
And be sure to stay tuned to future episodes of the MSDN Show, where we'll drill down even further into the technologies in the .NET architecture.
Thanks for joining us, and we'll see you on the web.